So hello everyone, my name is Amy Pellegrini. I'm a senior consultant developer at Thoughtworks for about 2 years. I have more or less 10 years of experience working mostly in the front end. And I have seen some of the challenges that the developers face in the front end. I have good experience with those. And I'm happy to have found some very interesting techniques that have been applied recently, and we're going to talk about those. So just to give you a little bit of a head up, we're going to talk about the challenges of front-end and user interface development, and then we're going to talk about Xstate, which is the tool I've chosen to focus for this talk. And I'm going to give just an overview of what Xstate is and some practices around state management related to finite state machines and the techniques related to those. So basically, the initial situation that we found is that user interface development is very hard because we are constantly facing challenging situations related to the behavior of the user in relation to their device. So humans are very unpredictable. And in the other hand, we have all the technical complications of handling potential different scenarios that could happen in a user interface, like the image you see in the background, and kind of represents that. We see the image of a plane, and you can imagine how challenging can be the design of that kind of user interface. So the problem statement I want to start with is that handling user interactions on web application state can be difficult given the unpredictable nature of human actors and the cascade of potential side effects caused by user interactions with the user interface. So the problem here is kind of exacerbated by the design that we have for our web. So the web is kind of built upon the client-server model, which relies on a client and a remote server. And what this does is kind of impose a situation where you have localized state in two different places, and then you have a global state, which the source of truth is usually the server. And you need to keep those synchronized. You have local state that can be independent, but then you have some global state that needs to be synchronized. And you have latency and reliability concerns because you need to handle the latency inherent to the web, different clients communicating from different places, like, for example, when you have a chat system. And then you have to handle the reliability of your system. If something goes wrong, the network is down, or there's some kind of problem, your system needs to keep working and keep providing all the requirements for the user as much as possible. So in this kind of landscape, what you will find is three major concerns that you need to worry about, which are race conditions, asynchronous events that will be happening either triggered by the users or by your own system, and then you have shared data between components. So for example, the classic situation, we have a implementer form, and we have seen this many times. And when we get the requirements, we see something like this. We see, a very simple form, some fields in there. We have a submit button, and we expect this to be easy, right? You just put the fields in there. User submits their information, they click the button, and everything is fine. But if you start going through the requirements in detail, you start noticing that this is not trivial at all, because the first thing to happen is that you don't want to submit an invalid request to your server that could cause errors. So first thing you want to do is just to disable the submit button, just so the user cannot click it by mistake, or just to send incorrect information or an empty form that will just create noise in your system. So once you have done that, you need to kind of ensure that the user will submit valid information, or they will not try to abuse the system in any way. Like, for example, they will not try to do kind of, an SQL injection attack or stuff like that, or they will submit incorrect information that then they will not be able to access because they have submitted an invalid email, or because their password, they put it with a specific keyboard setting, then they change the language and now they cannot type it anymore because they don't remember it. So you already have a situation where, for example, two different fields need to know about each other. The password and the confirmed password, they need to know about the state of each of those. So they need to share some information between each other. So once the user has hopefully put all the correct information in the correct format, you're ready to submit your form. Everything is fine. The form should be smart enough to know if it's valid or invalid. So when the user clicks the submit button, again, we need to disable the possibility of sending multiple requests. So you need to disable the button again. You also need to freeze all the fields because you don't want to give the impression that you may maybe be able to change the information in the last minute, and what could happen if you do that, you know. And then you need to give some kind of feedback to the user. This is happening in the background. You just wait a moment, and once the request is finished, hopefully it will be a success, but it could be that there is a failure too. So you need to inform the user there's been a failure. So you have different ramifications of the user flow that could happen. And I have seen like seasoned developers working in this kind of system time and time again. And we seem to fall into two categories. One is like those who really manage to implement it and they do it quickly and efficiently. But the resulting code maybe is not so nice to work with in the future. So if you want to add more fields or you want to add specific validation, then it turns out that extending the system is not so easy. And then there is another category, which is they just found it difficult. They start doing the validations and they start dealing with a lot of tiny edge cases or weird behaviors in the form. And it feels like at this point in time, we should be much more proficient at just implementing such a common user interface like this. So this brings us to what is Xstate. And I think Xstate is a great tool. And by the way, it's nothing to do with XConf. So the branding is purely coincidental. But Xstate is a JavaScript state management solution created by David Korshett. He was formerly a software developer at Microsoft. Now he's working independently. And he's the founder of Stately, which is kind of a forum community about issues or topics related to state management, state machines, and all the kind of academic background related to that. So I would like to notice that the concept of state machine and state management is a hard topic in computer science, and there is a lot of material out there. So these kind of forums are very interesting to participate in, and it's very useful to kind of get deeper knowledge about this. So basically what Xstate does is bring the concept of state machines to front-end development, which is something that we haven't done before. And just to give a quick overview, finite state machines, as defined in the Xstate docs, is a mathematical model of computation that describes the behavior of a system that can be in only one state at any given time. So the classic example is the traffic lights. So if you see the traffic lights, you hope that the traffic lights will not display ambiguous information. Maybe the yellow light could be tilting, while, I don't know, you have the green light and the yellow light is tilting, just letting you know that the red is coming, but you will never see the red and the green light at the same time, because that could be very dangerous, right? So it could be chaotic if your system behaved that way. And this is the same approach when you are, for example, in a submitting state in the form that we saw before. You don't want things related to validation to be happening because that's not necessary, and that could just create side effects that we don't need to deal at that point. So state machines are composed of 5 different parts: a finite set of states, a finite set of events that could happen, an initial state, a transition function, and a possibly empty set of final states. So we see a diagram on the right where we see a graphical representation of a state machine. And you can see you have the little squares representing different states. You see the arrows, which kind of represent the transitions. And the events are kind of things that could happen that could trigger a transition from a particular state to the next one. And the arrow with the little dot is the initial, is kind of representing where is your entry point or your initial state. So basically, you can see how well organized it is and how it helps you to think about your system and what things could happen. And one interesting constraint to mention is that when you're in a given state, any event that is not handled by that state will not be even triggered. So you don't need to deal with scenarios of user doing crazy things in the user interface, because the moment you are in a specific state, nothing else that happened will manage to have any impact in your system. So this is very interesting, but the question is, why should we choose Xstate, right? So there are so many tools out there. We have RxJS, which could be, by the way, could be used in conjunction with Xstate. You have Redux. You have things that you can do in your own. So this question is a very valid question. And to understand why I suggest to just see that this library is that just try to think about the challenges that you have and how would you solve them. So the usual application requirements in a rich modern front end is that you could have things like real-time updates, you have user notifications to handle, you have data synchronization, presentation, filtering, you have shared data between components. That can be components between your own user interface, or they can be remote components. You have a synchronous event happening, triggered by your system or triggered by the user. You have errors that could happen. You need to handle them. You have navigation. And you have to do that and provide a very nice user experience in the end, because you want the user experience to be consistent, the behavior to be consistent. So the same actions trigger the same consequences in the system. It's not flaky. The system is not doing weird things. It's not confusing your user with random errors. Or so you want to provide all of these features, and you want to do it in a way which is efficient and you can scale. And how you do that, right? So we had a situation with one of our clients where we had a kind of a challenging user interface like this. And we said, okay, how are we going to handle state management? So we decided to do an experiment. And this experiment, which we call a spike, so in Thoughtworks we use the concept of a spike, which is basically a short experiment. We decided we're going to choose a few tools and we're going to compare them. We're going to implement a subset feature of our system in 3 different tools. I'm going to see which one performs better in terms of ease of use, ease of implementation, support, etc. So we decided that there are 3 main areas we wanted to kind of cover for the tool of our choice. And one of those is there enough documentation, enough community support? If something goes wrong, do we have somebody we can call out for? And we listed 3 different options. So one was Xstate, the other one is Redux, and the other one is a custom solution that we decided to implement on our own. And and we also thought about what are the trade-offs, right? What's the ease of use of each of these solutions? Are they easy to implement? Maybe they are easy to implement, but they are not easy to scale in the future. Maybe they are harder to implement now, but that means that the future will be handled to manage if you want to expand the system. Maybe that means that our developers need to do some additional training just to learn how to use some tool. So all of these are kind of the different trade-offs that we need to consider when choosing the right tool. And we had the experience with Redux before. So Redux was a tool we knew very well. There is a big community around it. But we were not very happy about the state of things with Redux, because we found out that it tend to get very verbose, and you have all these different files scattered all over the place. You need to kind of design your test in a specific way just to work with Redux. And this was kind of something that we wanted to avoid. We wanted to know if there's any possibly a better choice for this. So we did a spike. It took a few days. And what we found out is that Xstate was filling all the bucket for us because it had the right balance of trade-offs. It was something relatively new for some people, but we were sure that they could catch up very quickly, and that's exactly what happened. It was quite easy to use. We just had to use one file. There was no reducers, containers, all this baggage around Redux. And there was a very strong community support around it. It's a relatively newer library compared to Redux, but there is already some momentum built around it. And for our custom solution, what we found out is that, yeah, it's quite easy for us to implement something that we feel comfortable about, and it's quite easy and straightforward, but we don't know what that means for the future. And we don't have any support or community around it because it's basically our own solution. We need to know, and we need to be responsible and accountable for it, and we cannot guarantee that. So we decided to go with Xstate. So let me walk you through some of the Xstate concepts and how is it useful. So the first concept is that your states can be hierarchical. So if you remember the case of the form that we were talking before, you have a global state form, which is basically telling you if the form is valid or is it valid, is it submitting, is it idle, just waiting for the user. All of these different states can be considered part of the global state of the form. And then you have local state for each of the components, which is the inputs they need to know if they are in a valid state or not. The submit button needs to know if it's disabled or enabled, and that's part of the local state of that specific component. So that means that the states can be nested. And that's what the concept of hierarchical states refers to, is that the ability to compose your state and make it like nested items, pretty much like you would build it with components and modules. The other concept is that you can have parallel states. So parallel states is like the orthogonal concept to the one of hierarchical states. So parallel states refer, for example, to the state of each input, which in this case is parallel, right? So each input doesn't need to know about the state of any of the other inputs. So these inputs doesn't need to know about the button. The username doesn't need to know about the email. They can be valid or invalid independently. And that's a very good thing, because that means that when you're working with a specific component, you don't need to worry about what is going on with any of the other components. So by being able to model your state as parallel, you already decide from the start what things are going to be interacting with each other and which things are kind of independent of each other. And that's very good to kind of model your system, because it gives you freedom to decide not only how to compose it into different modules, but also to know which modules are supposed to communicate with each other. So another very interesting concept, which is also a core concept of computer science, is the concept of actors. And Xstate brings the idea of actors in the form of observables or promises or state machines that can be kind of communicating with each other. So basically, the idea of an actor is, again, just quoting the Xstate docs. So the actor model is a mathematical model of message-based computation that simplifies how multiple entities or actors communicate with each other. So basically what they're saying is you can have, for example, different state machines that can send events to each other, or you can have different entities that you can consider as actors that send events to each other. So in this case, in the case of the form, you have a submit button that sends a submit request, And then you have a different entity, which is in this case a promise that will handle that request. So you could have, for example, maybe not even a promise, you could have an observable, or you could have another state machine, but in this case it would be a promise. And Xstate provides an interface for this. You have the emitter send and send parent. If you have nested state machines, you can send message to the parent state machines. And you have the handlers on error, on success for promises. So if a promise is rejected or if a promise is resolved, it will lead to different possible state, and Xstate is perfectly ready to support those kind of interactions. So I find that very useful, because it's not only that you're just modeling your state, you are also ready to kind of model states in a more global way and handle like independent actors talking to each other. So the last and final concept I want to talk about, and this is by no means comprehensive, so there is much more things to talk about, but I want to focus a little bit on state charts, which are kind of a visual tool to represent state machines. So state charts is a concept developed by David Harel. There is an academic paper he wrote in 1984, which is called A Visual Formalism for Complex Systems. And we could say complex system, as also known as state machines, and basically describes a visual formalism so that you can represent all of these interactions that we've been talking before. So for example, here we had this diagram that we saw before, and you have your different states and you have the different arrows. And this is just not some random drawing. There is very specific formal rules to kind of create these diagrams. And that means that you can have a design tool to ahead of time, ahead of the implementation of your system, you can start creating a design for your system, and you can try to see if there is any kind of ambiguous state or some kind of assumption that you got wrong, or is any isolated state that you cannot reach. You can kind of ahead of time try to see if there's going to be any kind of problem with your system. And there is a very nice resource. I'm going to jump out of the slide for a while, which is Xstate catalog. They have different kind of examples of state machines, and they have the visualizer that you can see. So you can see the state machine, and then you can see the visualizer, how they will handle all the interactions and the events, and you can play around with it. You can see what's going on, and you can reset it. And yeah, basically it's kind of, you can play around with your system and not just jump straight into implementation and maybe based on the wrong assumptions. So I think it's a great design tool that you can use, and I would like to see more of these tools used further ahead. So now that we've seen all of that, I would like to walk you through a musical example. Let me just jump out again. So I have my code. I'm going to start. So, okay, so I have some code here. Sorry that this, give me 1 second. Because I need to start my style guide list. And I forgot how to do that. Okay, what I'm going to do is just go to the website where I have this implemented. And so basically what I have is this example, which I have implemented, and this is the code, and we're going to walk a little bit through it. So I have a voicing chart generator. It's just a tool for musicians to practice music. And what this does is basically displays a basic voicing, which is kind of a sequence of chords that you can play around. And if you hit this, you can listen to music. And you have different things that you can do here. You can play with the chords. I can listen to this chord or this chord. I can see the keyboard layout, just trying to find myself around in the keyboard. Okay, what should I play, you know? And I can play with different voicing forms. So there are different arrangements. And basically, if you see, the moment I change the key, you see a loading here. And this loading is kind of stopping everything that could happen while we are loading the audio for this example. So I'm going to walk you a little bit through the code for this. And I want you to see the state machine. And in here, you can see the supported events that you have, which kind of helps with the event storming. When you do event storming, you can capture everything that could happen in your system, which is very useful. And you see the schema for the state machine, which is declarative, which for me is very powerful because declarative code is kind of very easy to read and understand. And I think that's helps a lot to simplify a lot of the issues that we've been discussing about. So we have a service that is going to load the audio, and this is our external actor. And we have our context, which is kind of like the extended information around the system, things that your system needs to know to properly represent what's going on. So you can see the state machine. You can see here, this is the external actor. This one is basically returning a promise. And when we enter into the loading state, this promise is invoked. And when this is done, it will transition to a default state. Or if there is a problem, the network is down, something happens, you can transition to a silent mode. There is a silent mode that you can use, and it will basically allow you to continue playing around with things without the audio, and it will not cause any errors. So you can see how you, right from the start, you can start thinking about the resilience of the system. And then you have all your different states, right? So you have the full state, you have the silent state, the playing state. And in this way, you can organize everything that is happening. And only, so for example, if I'm in a default state, only the events related to that state are the ones that will be handled. Anything else will not be triggering any kind of consequence. And I was playing around also with model-based testing, something I would like to discuss as well. So just very quickly, test, watch. I'm using so many watch commands, I usually tend to forget which one is the. So basically, this model is kind of like a representation of how I expect the behavior of my system to be. And in this case, we are using some techniques which are not new, but they're kind of forgotten or not used in front-end development so much. So in this case, what we are doing is use the library to create a Xstate test, which provides a create model interface. And if you provide a state machine and a subset of events, you can kind of create a model for your system. And I'm just going to show you very quickly how this works. So in this case, we have a state machine. And this is different from the actual code. This is just like an external representation of your system. You have the different states that you could have. And for each state, you have associated different assertions that you could do just to verify that the state is behaving in the correct way that you expect. And then you have different events that could happen and where would they transition. So then you have the model. So to the model, you pass the state machine, and then you pass a different sets of events. And what is the specific action that will trigger that event? So once have you done that, this model can generate path plans for you. So basically what will happen is you have automated test generation happening. You don't need to think about each of the possible cases yourself. You just have a model that will, on its own, it will be creating all the different possible scenarios that could happen. So if you think about your state, like, like different states are like nodes in a graph, right? And you have the different arrows. What this would do basically is try to connect all the arrows to all the possible states that are there. And it will tell you if there's some state that is unreachable, or if some of the assertions associated with each one of the states is incorrect. So I want to just see the test. So this one is going to run the test suite. And you see that there are some different tests happening here. And yeah, it's been trying to navigate from each of the possible states to the next one and doing assertions every time. And this was not written by me. This was automatically generated and executed by the model, which I think is very powerful too. So I'm sorry I overextended a little bit. Hopefully we have time for some questions.
Yeah, we should have time for questions. It's no problem. The next talk starts at 12:35, so we actually have plenty of time. Amy, cool. Thanks very much for your talk. I really like seeing these developments in front end where people are kind of finding innovative designs to solve hard problems. Like, I think at least when I started as a developer, front end was not treated with very much respect, and kind of, there was being an experienced front-end developer was almost just like a thing that didn't happen. It was kind of people just doing things. And so at that point in time, we never got these kind of really deep rethinkings of how to build applications. So it was really awesome for me to see you put the presentation together so clearly today. A question that Johannes has is, how does Xstate embed into other frameworks like Angular? I guess the question is, can you benefit from Xstate while using other frameworks, or do you have to go all in and say, I'm building an Xstate based application?
Yeah, okay, so I think that's a very good question. I have seen, so there are different tools out there. So for example, Xstate has some additional packages that you could use that integrate with different libraries like React, Vue, Svelte. So you have different integrations. But let's say, for example, the case of Angular, you don't have a specific Angular Xstate integration, but you can still use it anyway, because you can basically consume Xstate as a package like you would do with any other package. And as long as you keep that package kind of isolated, or you treat it like a dependency for your project, that's perfectly fine. So you can still use it, and you still have an interface to interact with it. So you can create an instance of a service and then listen to the events triggered by that service, and then check what's the state on that service, which is running your state machine. And you can be informed by that. And I'm quite sure you can integrate that with Angular.
Cool. And I guess the nice thing about that, if someone wants to try it out, they don't have to find an opportunity to write a brand new front end or change everything. They could probably find a way to use it to model some of their complex state in an application they already have that's working.
Yeah, exactly. So for example, in the case that I was talking before, we had some functionality already built in, and we decided to migrate to Xstate. And we found out that we could take small slices of our user interface and slowly start to move with Xstate. And that was perfectly fine. So Xstate was like a little island where things were organized. And yeah, you have this interface. So you basically can decide how much Xstate you want to use. And I think that's very good.
Cool, makes sense. So I've got a question here, which is, are you using React testing library to test Xstate, or what are you using there?
Yeah, so for the model-based testing, I'm using React testing library, but you can use any library that you want. So for example, you could use Puppeteer or something, or Cypress, to trigger this test in the browser and actually see it live in the browser. I've seen some presentations where they do that, and it's very impressive, because basically you see the model trigger every possible interactions and doing all the possible navigations to all the possible different screens in the browser, and everything is automated, and it's just fantastic to see. So I guess the point of interaction where you integrate the model-based test with your library is when you declare your state machine, you have different assertions that you can do, and basically this will receive whatever you want decide to give to it. So it could be Cypress, or it could be, in this case, it's React testing library. And then in the events, the same happens. You receive this, and you can interact with that in whatever way you think is more suitable. And then you do. Yeah.
Sorry, go on.
Yeah, so basically you need to, I mean, it takes a little bit of time to kind of get familiar with how this is built, but basically you can use any library that you choose to use for the testing, and use model-based testing with, with Xstate test.
Makes sense. And when you're talking about model-based testing, which I guess is that another word for property-based testing? Is there a similar, I don't know if you've heard that phrase.
Property-based testing.
So I think in some other contexts, it's like what you say, you generate and explore many different states, and then you have some properties that have to hold regardless of what states are generated. So I think some other people in the audience might be familiar with property-based testing as terminology.
Okay, yeah, well, it sounds like something slightly different, but it could be in the same vein. Like, yeah, I guess if you want to dig deep, you could find that, yeah, there are things that need to hold across all of the kind of different possible interactions in your system.
Yeah,
I think you could test that in this scenario. I think it's more related to the specific individual states.
Right.
Yeah,
that distinction makes sense. Yeah, because I guess one of the nice things, at least in the property-based testing approach, if you have these things that have to always hold, is it's a way of testing that some things never happen. So like often, I'm like, okay, I'm working an application. It should never be true that there's two modal dialogues open at once or something. And so like having a way to say, doesn't matter what the user does, what they do that we haven't thought of, or the fact they click on things in a weird order or a weird timing, it's never going to be true that there's two modal dialogues up at once. Can be quite powerful as well. And I think your Xstate-based approach probably makes modeling that state exploration really easy as well.
Yeah, I think by having the constraint, for example, in the scenario you mentioned, these two models would be like two different potential states, right? So
yeah,
by saying that there are two different states, basically the constraint imposed by Xstate is to say that they will never be at the same time, because it's like the traffic light sign, it's one state or it's the other state, but they could never be at the same time. You could add you could add some assertions in each of the states, checking, is this in this state, do we have two models open or not? And then your test will tell you, look, there are two models opening. I don't know, something is wrong. But yeah,
that makes sense. Yeah. It makes invalid states unrepresentable, I think, is a thing. Maybe even Kjeld is going to talk about thinking in types. So that's one of the things type people say a lot. If it's possible to make the invalid state just not happen ever in your system, you don't need to test it. It just is impossible.
Exactly. Yeah.
Cool. I've got one more question I want to cram in, because it's a really interesting one before we get to past and we head into break. Which is relating the state machines in your code to the state charts. Is there a tool, I guess, to live the dream of generating the data structures from the state charts, or maybe even vice versa, and generating the state charts from the code so that you know that the representation is correct?
Yeah, so basically you have two different tools. One is the visualizer that you have here. So if you go to the Xstate website, you can use this visualizer and you put the state machine in here and it will create this graph for you. It's a bit, sometimes has a limited use, and it's a bit difficult because if you have your state machine, usually you have also a lot of other baggage. So for example, in my case, I have TypeScript code. And because this kind of REPL doesn't support TypeScript, I cannot just paste it in there. But yeah, you can try to model your state machine like a smaller, simple version and put it there, and you can see it represented. The other tools that you have is, I think, is inspect or graph. One of these, you can basically inject on your application and open in the DevTools. And basically it will show your state machine in the DevTools.
Oh, cool.
I think that's really awesome. It's basically this same code that is creating this graph. You can kind of install it in your application and see it in the browser. And I think that's also very useful. So cool. before we finish, I just wanted to point to some of the kind of next steps or some of the resources to follow up. So of course, the Xstate website you can visit, and there is a lot of information there. The Xstate catalog that I was mentioning before, and the stately newsletter, I think is very good because you can receive like information and you can interact with the community around this. And there is a lot of information. So yeah.
Cool. Thanks very much for your talk. I've definitely used finite state machines in a similar way for banking systems to do things like make sure a payment doesn't get credited twice or whatever. And it's really interesting to see you use state machines for what is actually probably a much more complicated problem, which is user interfaces that have to deal with all the weird and wonderful things that our users put them through. So thanks very much, Amy. I really enjoyed it. I guess if folks want to ask you more detailed questions, you'll be on Slack for a little bit after, I hope.
Yeah.
Awesome.